Okay, thank you for the invitation to be here today with Michele Zoli from University of Milano, and I, Joël Aubin from INRAE, will present you the environmental assessment of circular system and the questions and results of the LCA application in the SIMTAP project. You will see that there are some ideas that are common with the previous presentation. So, to start, I wanted to come back about the modern linear aquaculture as it is conceived actually. You have a monospecific rearing systems with the same species in the same tanks. And actually it's linear because you give it the food it requires, and generally, most of the cases, I mean, in flow-through systems, in the cage systems, etc., you release the waste. And it asks many questions. The first one is due to biological limits. As you know, animals and fish is the same, will not fix all the nutrients you'll give, and they will release something like 70% of the nutrients you give them. And so it gives problems to the environment, and it is somehow costly. And it is more costly because some of the ingredients that you use in the aquafeed are coming from far. Okay, you have different types, soya, fish meal, fish oil, etc., and energy. So you can imagine that you will not fix only something to 20 to 30% of what you gave from these very costly produced ingredients. And moreover, there are questions associated to the monospecific culture with high density and problems of pathogens associated. So, and specifically with this idea of the nutrient release, you know that this study has been shown this morning also. It's about the biochemical flows here, and then you know that it's these biochemical flows overpass the limit of the planet. So it's a key question. So to guide the change, we propose to think about new circular aquaculture systems. And it seems to be a good approach to solve the nutrient loss hotspot at the minimum. But how can we be sure that we will not induce environmental impact transfer? And how can we be sure that the environmental gains are superior to the costs? So in the SIMTAP project, we use different approaches, life cycle assessment, which we will present you, and we also developed a multi-criteria decision analysis about sustainability through DEXI approach. Moreover, the LCA application in experimental framework, as it has just been shown before, raises several questions. One is how to propose an upscaling of the experimental results to an economic scale. As there is no reference value in LCA, how to conduct a fair comparison with reference systems, and what is the most appropriate functional unit for the multiple output systems as we have. So I will present you the solution that we used in the project. First, we propose the framework to guide the upscaling in 7 steps. The first is to the size of the farm, defining the size of the farm depending on the context. In the SIMTAP project, we are working in Italy, France, Malta, and Turkey. So depending on the context, the size of an economic size system should not be the same. So we first define together with the project guys the size of the farm, and we make the product balance because, as we had shown before, we have different products. There is this question of balance of the edible fish production of the product. And it's basically then we define the production style as the wonder shape, and is based also on the context. design the infrastructure, the size of the banks, the size of the cities, the plants, etc. Then we define the needs for consumable. Then we made an economic simulation based on needs, and then we this has not been done right, but we want to make an overall reference have this choosing the adequate reference. So to do that, we choose to find reference system in the same area as climate, economic, social, and physical context have influence. We produce the same main target species and reflecting the conventional practices. The illustration of A will be only the Italian and Turkish. SIMTAP reference for case studies, and we make a comparison on the basis of functional units within the different products of the systems in a single function. So one of the functions is feeding people, and we show that kilocalories produced by the system. And so one is earning money, so we use 1,000 euro of turnover, and we substitute results.
Milan? Yes, I'm Michele Zoli, Barcelona. We will see a presentation showing the reference system and the single system that we have evaluated with a CA. In particular, we collected data from two different offshore lands, one Italian and one Turkish farm, and one inland land in Italy. All these cases are characterized by a production of about several thousand of ton of fish per year, and we use primary data for feed composition and consumption, the juveniles, energy consumption, so both electricity, but also the fuel, the fish mortality, the oxygen consumption in the inland land, and the productive yield. We use secondary data for the nutrition and emission by fish metabolism, and so we have estimated better. We have estimated nutrient emission by fish metabolism, so we have used the mass balance model to measure the phosphorus emission based on the feed consumption, the characteristic of fish, the longevity, fish mortality, and the body composition. And finally, we have used a mix of primary and secondary data for CK.
Okay.
Okay, and we have used a mix of primary and secondary data for modeling CK on the fish as the difference. Back to the system, so use the method shown before. We have built two different scenarios visible with the random results. So the first scenario is called alternative feed, as Professor Parsi has presented before. So this alternative feed is composed by one social and produces solid, and so the fish are fed with this alternative feed. And we have set the target production target as 10 tons of fish per year. And according to this production, we have scaled up all the input and the output. And the most important thing to highlight is that if we want to uptake all the nitrogen available in the discharge from the fish production, we have a production of we have a production of 130 tons of silicon and several tons of polycate. And this product yield will affect the LSA results. The second scenario is the scenario where fish are fed with the commercial feed. And in the same way, we have scale of the input and output, and in this case, we have a huge amount of silicon and polycate produced. Coming to the results, I will present 4 different impact categories that are the more studied in the aquaculture sector, and the both of functional units. So on the left, we have results of the energetic functional unit. On the right, we have the economic functional unit. This result refers to the efficacy. We can see that the inland length is the most impactful for both functional units. The single system are most sustainable, while the energetic functional unit, the package offshore is the most sustainable. And regarding hotspot, we can see that the feed, the light blue part, is one of the main hotspots, followed by electricity, the orange part, the oxygen consumption for inland tank, and fuel consumption for the two offshore plants. On the other hand, in the purification is an impact category that is due to mainly the nitrogen and phosphorus emission in water, and so we have the synthesis system has a very low impact in this category for both functional unit, because we have California and polycate cannot take the nutrient emission, while for the other three case study, the results are very similar. Regarding global potential, in this case, the inland tank is not impactful. We have an opposite results with a functional unit and a functional unit. In particular, energy functional unit, the two reference offshore plants are less impactful with respect to the system, while the economic functional units, the system, are most sustainable. This is due to the fact that the difference between the energetic content of California and polycate with that of fish are higher than the difference of cost. And finally, with the cumulative energy demand, we have similar results in global warming. The inland plants is the most impactful. The unit difference with global warming potential is that the package offshore is a little more sustainable with the economic functional units than the one of the single system with very similar results. In this case, the main models are feed, electricity, and oxygen consumption in the inland. For the conclusion, so few ways to this presentation. So, as life cycle assessment is a robust framework that the details. As you saw, the transfer function of the functional unit is not only the communication, it reflects also the assessment goals and the objective of the producers and the promise of the project. So it's an important point. Our primary objective was to improve fish culture and co-cultivation of alpha fats, why
But at the end, we designed the same for a ton of fish and 130 tons of Saliconia. So it's really changed our point of view. So there is also a potential of improvement as you saw through nutritional loop in SIMTAP compared to the conventional systems that effect on nutrition, so that the feed composition and the resource and ingredients is the point. So there is a potential of improvement in nutritional loss reduction, and it has also high sensitivity to nutrition needs. Energy use and the related impact is hot in the recycling system in general, and particularly in our system. And the upscaling of experimental results is a delicate exercise according to this. And for study in the next steps, we'll include the uncertainty in the analysis to increase the robustness of the comparison, and we complete the environmental impact assessment and sustainability criteria assessment we use in the next year. Thank you for your attention.
Thank you.
We lose a lot of participants because of the problem we had. So I'm just asking you is the question, and even the participant, the online participant, if there is someone that was able to understand to listen the presentation, we are here the final question.
Thank you for the presentation. I will say more or less the same as what we had for the industries or for system producing different seafood. Can one functional unit be defined as the best one, or
So it depends on the purpose of the production system. And do you want to feed the people, or do you want to earn money? That's the point. And you see that in this for sure it's global. So maybe if it's the case, maybe we can have, and that's why I opened the idea about this XC approach. Maybe we can mix the two, and but it's not. I mean, it's not our role as scientists to decide for people who will settle this in their territory to decide what is the main objective. Maybe one of the objectives would be social aspects, and maybe the point would be to have most of the most working in this plans, because it will be more social than economic, and for the urban agriculture systems, it's sometimes the case, I would say. So, and there's another idea that we didn't present here, is that we could make allocation between the two production, but we find the same question on which parameter will you allocate? Will you allocate on the dry matter? Will you allocate on the energy content, or again on the value of the product? So the question is still open.
It's very interesting. I have a question and a curiosity. I start from the curiosity. When you value the case, you can value it for because of as a bait or a fish bait or as an ingredient for fish meal. And as far as we know, the value changes completely. So it's at least much better to sell the worms as base than as fish meal. So how we consider this in a thing like this is the curiosity. And the question is indicators that they consider. So do you see the possibility of extending this to we consider traditional methods that you use in aquaculture? But we know that there are some limits in the research about that. So my question is, I don't know if it's the question, but it's how can we extend this?
For the worms.
You mean the economic value?
Yes.
Okay, we consider an economic value due to the selling of the entire form in a gross selling. I don't know. Okay. The question, sorry, was to okay, okay,
Or
no, yeah, yeah, for the, yeah,
it was for the
yeah,
Okay. Okay. And about actually it's open. That's I'm feeling that we have to go to the best recommendation. I mean, product and that is with a list with this high list of impact. The problem is okay. Some of what's proposed by the budget is not precisely adapted to aquaculture. That's my opinion. And surely the aggregated to the single source doesn't fit to me. But however, it is more easy to compare with the single score, and so maybe we problem. It's still not a question for our project. We didn't finish this. However, what the inventory is really is just to change. But if you have some proposal, we're open. That's
Thank you. We're running a little bit late, and I have some notifications saying maybe you are just 5 or maybe another 3 minutes. But I think Michele was in zero. Yes, for the next question with a question. He wrote, I was thinking that perhaps from an economic point of view is that the cost of production should also be considered and not only value produced, because the MTA system eventually require more maintenance. So you think about it, for sure, all the are you all invited to answer if you want?
yes, it's right. Yes, it's right. You have to finish calculation of the and maybe we have to give you values to make this calculation. Yeah, yeah, that's right. It's not only the return that is but the margin that you gain from the sure.
So the other question is whether SCA is a super study test about aquaculture or whether are actually evaluating, for example, suicide.
Okay.
And for you are already to answer right now statistics.
So in the framework of the flex, there's not only environmental SDA, there's life cycle costing and social SDA also. And we decided to aggregate this with other indicators of social and also technical aspect of the profession, and we do that in a decision tree, and this decision tree is created through an open access system called DEXI, and that's to decide of the ratings, because the question is how to aggregate all of this into something that is understandable of sustainability. And so if you aggregate, generally use weighting for different criteria. So this is managed through the density pool. Yeah. So yes, we will take this into account.
Thank you. And thank you all for